Hello, class. It's me. I'm down here. Hello. So I'm switching it up a little bit. Week 6, pretty easy week. Just a reminder, you still have that extra bit of time this week to finish up the latest quiz. And some of the information that you will go over this week should be helpful for that if you haven't done the quiz yet. So I see a few of you already did it and you did awesome, so I guess it wasn't as hard as I thought. But anyway, so the material for this week, we're getting into confidence intervals, basically. And the learning objectives, you'll see, basically I'm going to cover them real quick here. And everything you see on the screen here, you'll have a copy of this Excel file because what's in here are some calculators or templates, if you will, for calculating confidence interval. It'll make your life significantly easier, not having to get caught up in the formulas and the like. So I mentioned previously last week the confidence interval and the mean. You can do it through the data analysis tool pack just by checking that box. However, when things get a little more complicated in terms of estimating information in regards to the population, okay, we get into this concept of a point estimate, and that's not a fancy term really for anything other than it's basically anything, any statistic or number that you have already known that's been previously calculated, whether it be for the population or for a larger sample. That's your point estimate that you would use to extrapolate your confidence interval from. So this is all on the screen here. So for example, if you know the population mean or standard deviation, you can use that as a point estimate. Or when you calculate a sample mean or standard deviation from your data, you can use that as a point estimate of the larger population mean or standard deviation. And again, so why is it important? Because with confidence intervals, this is basically an educated, really educated guess of where your sample mean is to the larger whole of the population, because that's what we're concerned about, okay? Anyway, so interpreting a confidence interval, this is kind of big, okay? So what you need to know is your confidence interval will always be set on some sort of significance level or confidence, degree of confidence you want to put in that. And typically it's either at 0.90 or more often 0.95, or if you want to be really precise, 0.99. So when you, and we'll go over the output in a minute here, but when you perform your confidence interval, the way you would interpret it when you get that range, that lower number and that upper number, is basically what you're saying is if you were to conduct this study a whole bunch of other times, many times, 95% of the confidence intervals or ranges that you would calculate would encapsulate the population mean under investigation. Okay, so it's not like 95% of the time or anything like that, or it's a probability of 95% if we're using 95% as the level. It's 95% or 90% or 99% of the confidence intervals would contain the population mean, okay? Just to make that clear. So what I have here in this spreadsheet or this workbook, it has this information in it, and then I give you a little calculator for calculating the confidence interval when you know the population standard deviation. So here, if all you would need to do is punch in the numbers, in this whole teal box is a data entry box, so you would put in, if you know the population standard deviation, you've already calculated a sample mean, you already know your sample size, and here you would just type in what that confidence level is. So like I said, 0.90, not 0.95 or 0.99. In this particular calculator, you don't have to put the decimal point in, you can just put it in as 95%. And then it does all the calculations for you. In the bottom here, it actually gives you the confidence interval. So again, in this particular example, we have a sample mean with a population standard deviation of 0.15, and it gives us a confidence interval of a lower limit of 89.96 and an upper limit of 90.04. It's saying 95% of the confidence intervals, the population mean would be in between that. So in this particular example, this sample mean is in between the lower and upper limit, so that's a good thing. It's not outside, it's not below it, it's not above it, it's in it, so it's good. So, like I said, you can just plug in any number here, and these calculations will automatically update. The other calculator I gave you is calculating the confidence interval when the standard deviation for the population is unknown. So here, you would have to calculate the sample mean and standard deviation. So I gave a little sample data set here, just to give you an example of that. And again, on the previous example, you could do it off raw data as well and just plug the numbers in here. So in this particular example, I'm showing you, here's a little small data set. I calculated the mean, I calculated the standard deviation, and I just have it pointing to those calculations. You can see by the cell references here. And then again, it calculates the confidence interval for you. So here I have a huge wide range because I have a tiny sample size. And look at the range, really, you can see it, is kind of proportional. The range of the data is proportional to the confidence interval and vice versa. So and this data goes from 21 to 135 with a confidence interval of 5.545 to 80.84. So obviously if I tighten that range a little bit to like 44, you can see how the confidence interval tightens up. So something to pay note to. The last confidence interval that we're going to go over is the confidence interval for a proportion. And this little calculator does it for you. So you would just plug in your overall sample size. The number of successes, okay, is basically how many times something occurred, okay, out of your sample size. So it calculates the proportion, which is right here. And then, again, you just plug in your confidence interval, and it gives you the confidence interval for a proportion, okay? And again, 95% of the confidence intervals would contain the proportion for the population. Same way to interpret it. So that's it for confidence intervals. You got the calculators, you know what a point estimate is, you know what a confidence interval is, how to interpret it. The last thing is about sample size we delve into this week. In here, there's not too much on the quizzes. I'll have to check the midterm and final about this. But here with this little handy dandy calculator, it does it for you as well. Here we're assuming we know the population standard deviation. We have an estimate of our sampling error. We just plug in our confidence interval, and this gives you an estimated sample size needed for whatever study you would, or data set you would venture into. So you have all these calculators, so you should be good to go. If you have any questions, just ask, because we have our first midterm exam next week, and there'll only be one for that. So I'm curious to see if that makes a difference, because these multiple attempts seem to be really boosting people's grades for the most part. So that's a good thing. So this will hopefully maybe balance this out, because I'll be honest with you, we professors get in trouble when we have too many A's, because usually it's a red flag that we're too good at our jobs. But like I said, these aren't really quizzes. They're meant for you to gain mastery for the harder tests like the midterm and final exam. So that is all. Let's have a great week, and if you have any questions, just ask.